Good evening, everybody. How you doing tonight? My name's Rick Alling. I am the director of the Martson Exploration Theater. You see it empty behind me because we're not having events at the theater during the pandemic, but we are visiting people on a regular basis online. And this is one of a series of virtual night skies. We do these on Wednesdays. Usually they're about every 2 weeks. We skipped one because of the Veterans Day holiday, but we're back and you're joining us tonight. And we have a really good crowd tonight. And I want to welcome members from the Barrett Honors College. I understand that this is one of your events that you're having, watching the night sky program for the next hour, and then also going out and enjoying the night sky. You couldn't have picked a better night. It's clear, the temperature is great, everything is looking good out there. So I'm really excited about the program tonight and helping you out. I'm going to do something very, very unusual. Nobody ever does this. We've just launched. It's 7 o'clock. You're here. We're getting started. And I'm going to send you outside. I'm going to say we're going to start at 7:05. We're going to start 5 minutes from now, 4.5 minutes from now with the regular program. But there's something going on outside that you should see right now. It is silly for us to do a program about astronomical phenomenon that you could see from your backyard when something amazing is happening right now, and you should go see it. You shouldn't be inside. So let's take a break. You're going to get up, go outside. You're going to look towards the southwest, and I want you to find the moon and the objects that are around the moon and look for one thing in particular. See if you can see evidence of earth shine. That is where the moon actually shows as a whole spherical ball. Even though one little sliver of it is lit, you can see the whole of the moon. Go do it. Come back. We're going to start at 7:05, and we'll see everybody then. I'm going to hang out as I see people join. I'm going to send them outside, but this is your chance to go. So I'm going to stop talking for a moment and go do it, and we'll start in just a couple minutes. All right, everybody, we're back. Thank you for indulging me with that. I hope many of you took advantage of that opportunity to go out, check out the moon. If you're back, I just sort of suggested to the audience that didn't go that there's an opportunity to see the moon starting to interact with the planets, and that by the end of our program, by 8 o'clock, when we're finishing up here and we get to go outside and check things out, it won't be as prominent. It'll be harder to see. And so I thought we better do that early rather than late. Let me introduce to you some of the team that's here tonight. So I'm Rick Alling, as I said, and I'm the director of the Martson Theater. I also, with colleagues, we are all part of what we call the Community Outreach Group. Kim Baptista is here. She's your webmaster. She's the one that does the communication, invites you to these programs and keeps track of all of that stuff. Thank you, Kim. Meg Hufford has been my colleague. We've worked together for 10, 12, 14, 13 years, something like that. And she's also sort of on board to do that. And 3 students tonight, Alicia Hyatt, Spoo Sripti Katchaway, and also Alex Blanche. And Alex actually is he's sharing his screen. He's using a program called Stellarium, and he's going to show you a little bit about that moon that you just looked at. Go ahead, Alex. Thanks.
All right, thank you so much, Rick. So, like Rick said, this is Stellarium. This is a free program. You can find that at stellarium.org. They also have a free web version called stellarium-web.org. These are handy tools, very advanced. The program's very robust. And so this is the moon right now. This is the current time. This is viewed from Phoenix. So as you can see, it is a waxing crescent. So you can see that crescent, it'll get larger and larger with each day. But you can see there's a slight little outline of the rest of the moon. It's darker, but that's just because, again, right now the Earth is giving off, it's reflecting a lot of light from the sun. And so that's shining back on the rest of the moon and illuminating that darker half. And so let's see, if we back out real quick. There we go. So this is the night sky right now. And what I'm going to bring up is something called the line of the ecliptic. This is the path the sun traces in the sky. And what's very interesting is over the next few nights, the moon is actually going to do something. It's going to move along this path. So as I advance from each day, this is going to be tomorrow, the next day. And as each day moves on, the moon is kind of going to follow underneath this line of the ecliptic. And by the 25th, which is the day before Thanksgiving, it's actually going to be right below Mars. So if you go out on the 25th, the night of the 25th, the moon is going to be very close to Mars. You're actually going to have a waxing gibbous now. You're going to have a little bit more of the moon illuminated. It's going to be a lot brighter. And then by Thanksgiving, oh, something seemed to have just, there we go. by Thanksgiving, it's actually going to keep moving, and then eventually it'll be a full moon and behind the horizon. So here we can see the full moon before that. But so this is actually it's gonna be tracing along this ecliptic. So if you keep note of where the moon is these following nights, you'll actually be able to kind of see where the sun traces out in the night sky. And remember, on the 25th, it's gonna be right below Mars. So you'll be able to see that waxing gibbous moon right below the bright orange dot of Mars, which is still fairly bright in the night sky and rises a little bit later. So back to Rick. That's kind of what you guys got to see tonight, hopefully. If not, if it was cloudy or rainy, unfortunately, that's the demo. But again, check out Stellarium if you have the opportunity. Very good program to see things in the night sky.
Excellent. Thank you very much, Alex. That was perfect. So I hope people got a chance to see that. And if you didn't, watch it over the next couple of nights because there's some really amazing things coming up. I'm going to take over the screen now, and tonight's program is really kind of special. It's one I look forward to. It's a story I look forward to telling, and I've done this in outdoor environments and in planetariums over the years. And it involves 6 constellations, some that we've already been introduced to. I'll sort of tell you which ones we've seen, and then we're going to introduce you to a whole new part of the sky tonight. And we're going to tell this really good, long story. There's some violence in this story. There's a young lady that is put into a precarious position. So this could be like maybe for mature audiences, but we'll keep it clean and we'll make it sure that the whole family can enjoy what we're seeing here. First of all, a little bit about where we've been and where we've been going. And so I'm going to use my pen to sketch here. But let's see, it was 3 weeks ago, we kind of looked at the watery worlds of that part of the sky. And we looked at Capricorn, and we noticed Aquarius was over here. Oops, sorry about that. I just sort of pressed the wrong button. We looked at Pisces. That's the fishes are also sort of right here in this particular part of the sky. And those are the 3 zodiac. Oops, I'm going to butcher my little fish over here. Those are the zodiac signs that we looked at. This one was called Pisces, right? And we also looked at a little sea monster here, a whale called Cetus. And Cetus is actually going to play in our story tonight. And we also looked at Pisces Austrinus and the famous star Fomalhaut right here. We talked a lot about Fomalhaut. This is where we were a couple of weeks ago. Let me just kind of like clear some of that. Let me show you where we're going. In 2 weeks, Alicia, who is with us tonight, is going to lead a big discussion about Orion. Can you see it down there just right on the horizon, right on the east? It isn't quite up yet, but in a couple of weeks, it'll be rising a little bit earlier. And then by 8:30, 9 o'clock, Orion will enter our night sky. We're going to sort of celebrate Orion coming back. We're going to talk a lot about Orion. And then Alex and another student named Liam, who you haven't met, are also going to talk about a space grant project and some cosmology that they're working on. So that's 2 weeks from tonight. And then we are going to have another program on December the 16th, and we're closing down for a little bit. In January, we'll start to tackle some more zodiac signs. So Aries is here, Taurus is here, Gemini is here, Cancer is down here. And if you've been with us since we started these night skies way back in May, you'll start to realize we're kind of heading back to the beginning again. We will be in the spring going a full cycle and ending up sort of back where we started. And that'll be kind of fun. So tonight, something a little different. We're going to tackle this part of the sky. I'm going to kind of cover the constellations. Oops, went too far. That kind of are surrounding in this particular area right here. And we're going to do it in order. There's going to be 6 of them. There's 1 and 2 and 3 and 4. We're going to talk about Cetus again. I'm going to introduce you to a new one over here, and we're going to go back up to that great square that we looked at about 5 weeks ago. And so this is really the story is going to play out in this part of the sky. You can see we're in the eastern horizon. Everything above that green smotch is in the sky. I've got this set up so it's what the sky looks like at 8 o'clock tonight. So it is at the conclusion of the program. I'll point out to you as we go some of the things that are easy to find, and we'll send you out there looking for them. We'll sort of point out some of the things that are a little harder to find in a night sky like we have in the Phoenix Basin, but that's how that'll work. I should also acknowledge that Uranus the planet and Neptune, the planet, are up in the sky right now, but those are invisible to you. You won't see them. It takes a telescope. It takes a fairly nice telescope to see those in the night sky, and I hope you have a chance to do that. Mars, on the other hand, is large and in charge. And so if you're looking for the part of the sky we're talking about tonight, sort of you're going to be facing east. We're going to sort of be in the eastern part of the horizon, down towards the south and up towards the northeast, down towards the southeast, and Mars is going to be sort of in the center right part of our scene tonight. So that's really how we're doing this. I'm going to clear all this out, and I'm going to get started. I'm going to introduce you to the first two constellations. The way this is going to work is I'm going to play out this story. I'm going to talk to you about the constellations and some science within the constellations as it happens. We're also going to send it back to you. So periodically during the story, as this plays out over the next half hour, we're going to go back to you and ask you some poll questions. Maybe you can help follow us along. Maybe you heard the story before and you know what happens next. We'll see how this works. And we're going to try to have a little fun with it, and we'll try to keep it going and keep it lively. The first one I'm going to talk about is right over here. This is called Cassiopeia. You might already know Cassiopeia. Some people call it the Queen's Throne. Cassiopeia was the queen of Ethiopia, not the Ethiopia we know today, but an ancient Ethiopia. And it was on the seacoast. And Cassiopeia was the queen. Her husband, Cephas, was the king. And his constellation is just up over here. And I like to sort of like think of Cassiopeia as the W or M in the sky. It's pretty easy to see. A lot of people already know that one. Cephas is going to be a little bit harder to find, but you'll see it. I think of it as kind of like an upside down house. And you might or might not know that this little star right down here is actually part of the constellation, but it's fairly dim and not very good. But look how close it is to the North Star. So this is the North Star. It's Polaris, and these two constellations, Cephas and Cassiopeia, are in that part of the sky. I'm going to kind of just go to Cassiopeia now and show you a little bit of science about it. So let me just change screens real quick. Oops, if I can. Maybe I can't change screens real quick. Let me just do it this way. And let me just draw the M again so you can see. And now the names of some of these stars are up here. So I'm going to go here, 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 and here. In the past, during our conversations, we've talked about a way of naming the stars using the Greek alphabet. And so many stars have what we call proper names, and you can see them on the screen here. You see Kaf and Shadar and Archid, Navi, Rubak. You know, so you can sort of see how those work. Those are proper names, but all of these stars also have sort of an encoded name, and it uses the Greek alphabet. And typically, it starts with the brightest star as Alpha, and then Beta, Gamma, Delta, all the way down to Omega, which is the dimmest star in the constellation. In this particular case, I'm going to introduce you to these, so you'll see sort of how this works. This is the alpha star of Cassiopeia, and so you can say Alpha Cassiopeia, and that means that it's the alpha star belonging to that constellation. Here is Beta. Here is Gamma. That would be the next one right here. Here is Delta. Epsilon. This one is called Zeta. It doesn't have a proper name, and this is the one I wanted to point out. This one right here is Eta Cassiopeia. This is what, the seventh letter of the Greek alphabet. It's not the brightest star in Cassiopeia. It has a proper name called Acherd. And it is a very special star. And I pointed out because it has some relevance to you and your sun. It is the same size as your sun, the same mass. It's the same color as your sun, and essentially the same brightness where it is in space. It's 20 light years away. So it's not the closest star to us. There are some that are closer, but it's relatively close. It's kind of in our neighborhood, as you might think of it. And it is what the sun would look like if you were 20 light years away from the sun. So if we could take a sort of a fanciful journey, go to Eta Cassiopeia and just kind of turn around and look back, our sun would look like that. You know, how bright our sun is, that star is in our day, how it sort of gives us light everywhere. It's so bright you can't even look at it. That's our sun, but there are many, many, many other suns in the night sky. Most of the sky you see are bigger and brighter stars than ours. So this is an example, kind of one of those rare examples, easy to find in the night sky, and one that is essentially just like your sun, 20 light years away. So when you find that, it's easy to find. It's kind of embedded in or part of the big W or M. It's just kind of like right here. You will be able to see it from the city, and just kind of take a look at it and just think for a second what our sun would look like if we were far, far away and looking back. I'm going to move ahead a little bit and to talk a little bit about Cephas. And then we'll start the first poll here. So Cassiopeia the Queen, she is right here. Here's that star we were just looking at. Now I'm going to kind of redo Cephas over here for a second. And I'm going to point out another very important star. Here we go with the alphabet again. Alpha, beta, gamma, delta over here. And this one is zeta, and this one is eta over here. Delta Cephei might be one of the most important stars in the entire night sky. And it's not very bright. It would actually be kind of hard to find. In fact, if I didn't point it out to you, this is in a kind of a darker part of the sky. It's surrounded by much bigger and brighter constellations. But Delta Cephei is actually something that's really, really important to us. It's a variable star. That means it changes brightness. And changing brightness, variable stars kind of come in two different varieties. This one is called a pulsating variable. So that means it's actually just sitting there on a regular basis, getting a little bit dimmer and then getting a little bit brighter and then a little bit dimmer. Its curve is about 5.8 days long. Let's see if I can sort of like draw it for you over here. It drops very, very quickly, and then it takes a long, long time to build back up. And then it drops again fairly quickly, and then it takes a long time. And it's about 5.8 days between. It loses a full magnitude. So it starts out in this particular star. It's a magnitude 3 when it's at the top, 3.4, and it's a magnitude 4.3 when it's at the bottom. So that's a big drop. It was discovered back in 1784 that it was actually a variable star, but something happened at the turn of the last century that's even more important. I don't know if you've ever heard of Henrietta Leavitt, but she was a researcher at the Harvard Observatory. And she was one of those people that sort of like was really doggedly dealing with the data, dealing with the details of stars and measuring and calculating the data and trying to find relationships. She was the one that discovered that this star had some special properties. She was studying a Cephid variable, one just like this, in the Large Magellanic Cloud. And she discovered many of them, and she discovered that there was a relationship between the period of their pulses and the brightness of the star where it is in space. And so if you know how bright a star is where it is, like we were talking about that sun 20 light years away, then you can actually tell how far away it is. So they were able to accurately measure the distance to the Large Magellanic Cloud for the first time because of Cephid variables. It's a type of star that we find in other galaxies across the board. It's a type of star that has finally gave us the ability to sort of measure distance. The space is vast. This has gone so far. In the 90s, the Hubble Space Telescope observed a Cephid variable in a galaxy called M100. It was 56 million light years away. It at the time was the furthest distant object that we had an accurate measurement for because of Cephid variables, because of the work that Henrietta Leavitt did in the early part of the 20th century. So I sort of maintain that particular star is one of the most important in the entire night sky. Okay, the king and queen. We better get back to the story. Cassiopeia and Cephas sit here in this particular part of the sky. And the story kind of goes that they were having a conversation one night after dinner. And the queen kind of let out something that starts the story. She did something that actually was kind of horribly wrong. I'm going to just launch a poll, see if you know what happened next. And we'll see if you guys are following and if you know the story. Here we go.
What does Queen Cassiopeia do that starts the adventure? She asks Cephas to do the dishes for once. She is boastful about her and her daughter's beauty, I believe is what it's supposed to say. It's cut off there. And then the third option is she accidentally shuts her dog's tail in the door. So go ahead and answer that.
Oh my God, everybody already knows. Okay, some people are playing with the dog's tail story. That's good. And I sort of like that one too. Okay. Oh, okay. It's pretty obvious. You know what's going on here. So back in the day, one of the things that you weren't supposed to do is be boastful. So here's what she did. Here's how bad it was. She was talking to her husband, the king, Cephas, and she says, Cephi, she called her Cephi. Cephi, aren't I the most beautiful queen in all of the kingdoms in all of the world? And Cephi says, well, of course, my dear. Why would you even ask? And then she went on to say, and our daughter, our beautiful daughter Andromeda, isn't she more beautiful than the nymphs that serve Neptune in the mighty sea? Oh my gosh, you're not supposed to do that. That was a really, really bad thing to do. So let me sort of like introduce you to the new character in the play, the daughter, and she is here in the sky. Andromeda, you might remember a couple of weeks ago here, let me shut off my poll. You guys did a really good job, by the way. Several weeks ago, I asked you to go out in the night sky and look for the Great Square. We called it Mariner's Square. It was just kind of rising back then, but now it's kind of well above the horizon. And it almost forms kind of a perfect square in the sky. Let me darken that a little bit so you can see it. I'm going to be being too careful with my dotted lines. And you found it. This particular star right here is going to be the closest one to Mars. And so you should be able to find this tonight. That would be very easy. And this one over here, the one sort of on the north side, has a name. It's called Alpheratz. And it also is one of those peculiar stars that actually is part of two different constellations. It's part of the square, and then therefore Pegasus, who we're going to meet later, but it also is the head of Andromeda. And so you can see Andromeda by just sort of following these particular lines down like this, and these particular lines down like this. It's pretty easy to do. Two sort of like sweeping lines, and that's where she goes. There's a little bit of science here, and I better sort of talk about it now because I don't want to lose this this opportunity. Andromeda is the daughter of the king and queen, and she is going to become an integral part of our story. But before we go there, I just wanted to show you something about Andromeda, and I'm actually going to change views here a little bit. I'm going to go to another program. This is called Sky Safari Pro. I'm sorry about that. I sort of like lost my way there a little bit. And let me sort of like this shaded for you. Now it's going to be white, but I can show you sort of what this. Here's that great square. Here's the star we're looking at. Here's Andromeda going down this way. Andromeda going down this way. Just wanted to show you something. There is right here a major galaxy in Andromeda. It's nowhere near us. It's way, way out there. It's called the Andromeda Galaxy. You might have found it. And I'm going to just show you tonight how to find it. It's actually relatively simple. You probably will not be able to see it from the city lights. So you're going to have to like check this one into your brain. Know that there's a way to find this, and we'll deal with it later. You come from the head of Andromeda, Alpheratz over here, and you come down 2 stars. You're going to go here and here. Bink and bink, like that. And then you're going to kind of just turn and go up 2 stars, 1 and 2, bink and bink. And right there, just sort of like just right there in the sky, it will look to your sky like a little smudge, but in reality, it's absolutely just a really, really gorgeous galaxy. So let me show you what it looks like in for real. Just let me sort of get it up here. Got to get my sky oriented correctly so I can see where I am. Southeast, east. There it is. There it is. I'm going to kind of put this on here. I'm going to center that selection. We're going to zoom in a little bit. Look at that. This galaxy, the Andromeda Galaxy, is a sister to our galaxy. We think they're about the same size. And these are called barred spirals. So in the center, there's kind of an elongated central bulge, and then these beautiful spiral arms going out. This galaxy is about 2 million light years away. And you can see it in the night sky. It will look like a little smudge. It'll look like a sort of something you can't quite even focus on. You can see in a dark sky, right? When you're away from the city lights, it's like a little oval. It's kind of got a little bit of shape to it, and it's a little bit sort of cloudy. But we've been able to now photograph it and detail it with amazing precision. And what we learn by looking at something like the Andromeda Galaxy is a lot about our galaxy, because remember, we're embedded in a galaxy. We're sort of inside. And as we look across the surface of our galaxy, we're limited on being able to see all the way to the other side. The edges become a little obscure. We know a lot about our area of our galaxy, but we don't have the advantage of getting away, way far away, and looking back and seeing what our galaxy actually looks like. So that's kind of part of the story here. And in Andromeda, an ancient constellation that plays in our story, is also one of the most important galaxies. It's kind of nearby, it's close to us, and it tells us an awful lot about ourselves. Let me talk to you a little bit more about Andromeda. I'm going to change colors here a little bit, just so we can sort of like do something. Her head is up this way, and I'll just try to sketch a little bit. Sort of, here's a big, huge puffy sleeve. One arm goes out this way. Here's another kind of puffy sleeve, and an arm goes up this way. She's wearing a kind of a dress tied in the middle there. You can sort of see the bottom of her gown right here, little feeties sticking out, and there she is. That's kind of her. So Cassiopeia, Cephas the king, Andromeda the daughter. Okay, so Neptune hears what Cassiopeia said and says, I have to punish this group, right? You can't get away from being boastful, and you especially can't get away with pretending that you have something, some more beauty than the nymphs in the sea. That is insulting, and you can't do it. So he offered them a couple of choices. I'm going to go to another poll here. You see if you sort of know which one they choose. They had a choice. They could choose their own punishment. Let's see what it did.
Neptune only offers two choices. Which one do they choose? He will send a tidal wave to destroy the country, or the king and queen sacrifice their daughter to a sea monster.
I would say we have just about the smartest audience in the world. Maybe you've heard this story before. Does anybody know this was actually a movie? What was it, about 10, 12 years ago, called, what was it called? I can't remember now. Anyway, so Hollywood picked this up. It's actually a story that's been told for 3,000 years, I would say. Okay, well, thank you very much. You guys got it right. They're going to sacrifice the daughter. So I'm just going to kind of add some chains here. And in reality, this is sort of how this is depicted. When you look at ancient star charts, the way sort of people sort of memorialize the sky and add this, she is not just sort of like stretched out like she's singing to the hills. She's actually chained to a rock. And the way this layout works, right? The king and queen and their palace and the surrounding village are up on a cliff top just over a beach. And they take the daughter down to a beach. The beach has these big, huge rocks. They chain her to a rock. And the idea is that a sea monster is going to come along, going to find that the young lady is helpless. She's chained to a rock, and the sea monster is going to eat her. That's what's going to happen. That's how the sacrifice is going to work. So the entire country is up on top of the cliffs. They're up there and they're watching and they're cheering and they're yelling and all this stuff. And they're just watching anxious anticipation. And then finally they see it. The monster starts to roll out of the sea, and he gets closer and closer to the beach. And then they can start to see his shape, and they can see that. And he's kind of gnarly and he's got all this kind of stuff. Let me sort of show you where the monster is. So we actually talked about this a couple of weeks ago. So Cephas, right here, the big, huge whale thing, it's just sort of like is going to become our monster. I'm going to give him a gigantic mouth here with sharp teeth, some gnarly things growing out of the top of his head. He's got some sort of funny little fin thing going this way, and then a big, gigantic sort of monstrous tail over this way, and there he is, a kraken, if you want. It's not really a whale. He's right. Oh, actually, I have. Let me just show you something. I got a little sort of like this thing over here we can take a look at. This is what it looks like in ancient sea charts. You can see that this is a gnarly character. He is something you wouldn't want to confront, and you wouldn't want to be chained to a rock. Oh, look up here on the top of the screen, sort of up over towards the right there, you can see Andromeda's little arm and the chain and sort of like that kind of stuff. This is sort of, like I say, the story has been going on forever. This particular chart was actually made in the 19th century, but it sort of like borrows on things that have been going on for a long time. Let me sort of go back to our story if I can. Let's see, I sort of like do it here. So now you have your sea monster, you have Andromeda, you have the entire sort of countryside is watching this activity, sort of like getting closer, 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 and all this stuff. And just at the moment before they think this is curtains for Andromeda, and this has got to be the end of the story. There's another thing that happens. We need a hero, and we have heroes in mythology. It's sort of like, let me point him out to you here. There is a hero, and his name is Perseus. And he actually sort of is up in this part of the sky, and I sort of like just outlined it here for you, right over here, right over here. Actually, I have a little sort of better drawing of Perseus as well, I think, in my bag of tricks here. Here's sort of what it looks like. I'm going to just kind of draw it down like this, and I'm going to go out here. I'm going to actually point out this star right here. Very, very important star. I'm going to save the discussion about that star until the very end of our story, but I'll sort of just give you sort of the shape of Perseus, see how to find it. There's this long sort of like arcing kind of thing that comes down this way, a little sort of like bend at the end over there. It doesn't look like much, but this is Perseus. And Perseus is also carrying a treasure he got from his last adventure. He's flying over on a flying horse. He just happens to get there at exactly the right time. He's flying over. He sees all the commotion. He sees everybody sitting on top of the hills. He sees all the yelling and screaming and crying and all the stuff that's going on. He sees the beautiful young lady tied to the rock, and he sees the monster just about to go get it. And so I'm going to introduce you to sort of like what Perseus is just coming back from. There was another adventure he was on. So he was asked to go find the Gorgon sisters. The Gorgon sisters were exceptionally ugly people, and they were causing all kinds of problems. And everybody around said, we've got to finally take care of this problem. We got to deal with them. The lead sister was named Medusa. And so the idea is that Perseus was going to go find the sisters, identify Medusa, off with her head, and bring it back to Athena, who was giving him the instructions. So this is his goal. So he's actually just coming back from that message. Let me just sort of ask another quick poll question here. Before I go forward, Medusa had a very, very special power. Let's see if you guys know what it was.
I'm sorry, technical difficulties.
It's
All right. What is Medusa's power? She's handy with a whip. She conjures special poisons, or she can turn those who look at her into stone. So go ahead and cast your votes down below.
My goodness sakes, you guys are so good. Look at this. I don't even need to be here. You guys can tell the story yourself. This is really perfect. Yeah, she turns to stone. So here's how he did it, right? How does he find her? How does he look at her? How does he slice the head off? Well, Athena gave him this shield, right? And it was made out of silver, and he polished the outside of it so that it became mirror-like. You could look in the shield, you could see it. And so they figured out, right, if Perseus actually sort of looks through the mirror and finds Medusa that way, doesn't look at her directly, but he can identify her and then pull out the sword off with her head, and there you go. I have a sort of here's a little view of Perseus, and you can see how this works. See how sort of he's always sort of seen with the sword. In fact, in this particular case, there's a little blood still on the sword there. He's got the head, and so he's flying back right on Pegasus, the flying horse, and he's got the head in a pouch, and he's flying over, and he sees the commotion going on. He's a hero. He knew exactly what to do, right? Well, he didn't know everything, but he knew that he had to do something. So he drops down, right, gets right in between Andromeda and the sea monster, and just in the nick of time, right? So just as the sea monster is just about to like gobble her down, and then the quick thinking Perseus knows exactly what to do. He takes the head, pulls it out of the pouch, so shows it to the sea monster, and the sea monster instantly turns to stone. There you go. He lets the girl loose, And, well, let me just ask this. What happens next? They sort of get away, but how do they get away? How do they make their exit? I'll sort of like do one more poll and then kind of get on with it.
How do our heroes make their exit? They drive their Chevy to the levee, but unfortunately, the levee was dry. Mom and Dad gave them a ship and a bunch of oarsmen, or they remember that they have a flying horse.
Yeah, how could you forget? This big, huge white flying horse. Oh yeah, okay, yeah, that's what we're gonna do. Yeah, that's it. So essentially, that's how this works. And I'm gonna kind of. Did I lose my share? Oh, hang on just a second here.
You're still sharing, Rick.
I'm still sharing. Okay, I'm just seeing something else on my screen here. So let me just kind of go back to our scene and let me sort of finish sketching this out. So here's Perseus, and I wanted to show you sort of one more thing about Perseus, and then I'll introduce you to a flying horse. Now I'm going to show you a flying horse, and then I'll introduce one more thing about Perseus. So here we are right here. Here's our thing. So the great square that we were talking about also actually serves as the body of Perseus or Pegasus, the flying horse. So we're going to sort of imagine a big wing coming up this way. And here's the horse's back. We've got horse legs coming out the front here. His head is actually sort of like off the screen in this particular direction. And that's kind of where he is. And so Perseus and Andromeda jump on the back of the horse and off they go. Now, let me show you this one more thing about Perseus that's very, very important. I'm going to lose the pen markings that are there. I'm going to sort of do this a little bit. Algo, remember that story? Algo is also a variable star. But remember, I said there's kind of two different kinds of variables. We talked about Delta Cephei and how important that was and how it's a pulsating star. Algo is actually what we call an eclipsing binary. That means a darker star is moving in front of it and it loses brightness very suddenly. And then as the darker star moves away, it brightens back up again. It's got a light curve that looks a little bit like this. And so you can sort of see how this works. This is only 2.8 days. So in less than 3 days, right, Algol will drop an entire magnitude plus a little bit, and it suddenly get very dim, and then suddenly kind of go right back up again to normal brightness. So unlike the Cepheid variable that has more of a gentle curve and a rolling thing, Algol looks very normal for a period of time and then drops and then comes right back again. Ancient people knew this. They could see this happening. And let me just sort of like launch my little thing again here. And whip back to my scene. Oops, I'm going to go to Perseus. Wait, what's this right here? So remember, we were sort of like looking at this particular area over here. This is Perseus, and here's Algo right here. This particular Algo means Demon Eye. And if I can do this, I'm just going to kind of like just draw in sort of the face of a gnarly Medusa right here. This is going to be one of her eyes. She's got another eye over here. She's got snakes coming out of her head. And so this in the sky, in the stars, in the mythology is Medusa's head kind of hanging off the belt of Perseus. These stars around it over here are called Gorgonia Secunda, Gorgonia Tertia, Gorgonia Quarta, and then Algo also has a second name called Gorgonia Prima. All of those stars are sort of associated with this particular story, this particular mythology. But the star itself, that's the important thing. For whatever reason, they decided to make the eye of Medusa the star that is also winking, the star that is actually sort of like doing this funny little motion. So thousands and thousands of years ago, they had they had a view of the night sky. They identified this particular star's quality, its little funny property of like winking or blinking out in a very, very regular period of time. And that's where they chose to put Medusa's head. That's where they chose to sort of put this story and lay it out in the night sky. And you can go out and see it now. I also just looked up, just so you know, our next program is on December the 2nd. It also at 11:56, I'll tell you about this on December 2nd. If you come join us at the Wednesday show at 11:56 that night, that's when we're going to see a very good minima of algal, the Demon Eye of Medusa. And we should be able to actually watch for it. It will also be sort of at the end of one meteor shower, at kind of the beginning of another meteor shower. And so we should be able to see algal winking at us, and we should be able to maybe sort of catch some meteorites if we're out there just before midnight on December the 2nd. So we're going to try to do that. Come back and join us at the Wednesday conference. We've got some more to talk about tonight, but I'm done with my story. We're going to take a break. I wanted to sort of thank you for kind of participating in that. It's a huge part of the sky. Many, many constellations that interact with each other and are all part of the same story. A story, like I said, that's 3,000 years old, and we're still telling it today. So I'm going to kind of just unshare my screen. I'm going to turn the conversation. We have just a moment to have some questions, and then I'm going to introduce one of the students, Spurti Kachai. She's going to talk to you a little bit about the meteor shower that's going on right now. So thank you very much for hearing that. Okay.
Okay, thanks, Rick. Do you want to stop sharing?
Oh, that's right. I'm supposed to
Screen.
sharing this, right? It's a little hard to do on this thing, but I'll do it. Here we go. Okay, got it.
I already
Perfect.
stopped it.
Thank you.
Okay. So what we're going to talk about is we have a few questions we're going to go over. The first one is actually from Selena, and she asks how her friend Dawn, who is watching from New Jersey, how she can relate tonight's lesson to her region of the night sky. So, you know, we're all locally here from Arizona. We're Arizona State University, but there are people watching from all over the country, and, you know, we're not in the same place, so we don't get to see the same night sky. Um, that's when I'd recommend really checking out one of these free programs like Stellarium, or I know like in your phone, some of those app stores have really great night sky apps. You can take some of these lessons and find where they are in the night sky or find these objects using those apps. And they may not be in the same spot, but they'll still be the same stars. So really, that's a good opportunity to use those apps and use those applications to find more about where you are and what your night sky looks like compared to like what we see here in Arizona. And then Robert asks to explain the brightness scale for stars. So we refer to the brightness of stars in levels of magnitude. Magnitude has kind of a weird scale where it actually goes from positive numbers to 0 and then negative numbers. So the larger number is, the dimmer it is, and the more negative a number is, the brighter it is. So our star is in like the negative, I think it's about negative 25, a little bit more than that. And then our moon's about negative 10. And then the dimmest stars that we've ever seen, or the dimmest galaxies we've ever seen, are at a magnitude of like 30. So it's an interesting scale. It's kind of backwards, but that's how we view that. So our sun is negative the way we perceive it. And then the dimmest objects we've ever seen in the universe are about 30. And then the last question is from Jesse. He's been reading about the TRAPPIST system that's about 40 light years away from Earth. And he asked, will we ever be able to send humans to that Earth-like planet? We always hear about these exoplanets that are Earth-like, and they're, tens, if not hundreds, thousands, or millions of light years away from us. And we always think, what's the future for traveling to objects like that? And unfortunately, at least in the near future and how we understand physics, it's very unlikely that we'd be able to actually travel to those bodies, at least in our lifetimes or even generational lifetimes, because the amount of time and the advanced technology we need to get there is just phenomenal. Because a system that's 40 light years away, it takes light 40 years to get there. And since light's faster than it's the fastest thing in the universe, and we can't travel that speed because matter doesn't like to move that fast. We actually can't get there. It would take us longer than 40 years, and that's even if we're moving it so close to the speed of light, which right now is physically impossible. So it would take us most likely hundreds, if not thousands of years to reach a system like that. And so really interstellar travel at the moment isn't exactly possible and is a little bit more difficult. So there are some questions. I'm going to hand it over now to Rick or Spoo. Or we hand it right to Spoo?
Or both, yeah. So let me just introduce Spurti Katcheray. She's been actually with us from the very, very beginning. So there's a handful of students you're meeting tonight. Alicia was helping with the polls. You just met Alex, and Spurti is the third of the student trio that's been doing these things from the get-go. You're going to see them a lot more in 2 weeks. They're going to basically kind of run the show for us in a couple of weeks, and that'll be kind of very, very nice. I asked Spurti just to kind of give us the lowdown on the Leonid meteor shower. You probably have heard of it on the news lately. Let's let her tell you what's going on and what to look for if you can find anything.
All right, thank you, Rick. So I'm just going to quickly share my screen here. Let me start off by introducing what meteor showers are. So meteors are essentially small space rocks that burn up in the Earth's atmosphere. Small space rocks or meteorites that burn up in the Earth's atmosphere are called meteors. When there are many such small space rocks in a short period of time, say 10 days or 15 days, we call it a meteor shower. So where did all these small rocks come from at the same place? So in our solar system, along with planets, their moons, and asteroids, we also have comets. Now, comets have different orbits. They might not be in the plane of the ecliptic, but they do have their own very own orbit around the sun. So as you can see, a comet's orbit intersects the Earth's orbit, or could intersect, or could not, and maybe it does not intersect. So comets are mostly made up of icy matter, dust, and gases. So when they are closer to the sun, a lot of this icy surface boils off and lets out a whole bunch of debris and small rocks. So since it's closer to the sun, it's kind of in the inner solar system. And lucky for us, we are also in the inner solar system, and so we actually cross the path of these comet trails and comet paths and their debris. So when the Earth's orbit and the comet's orbit cross paths, the Earth's atmosphere burns up any debris that is in that orbit, and we see that as a meteor shower. So this is why we see meteor showers annually, because comets, since they have an orbit, they also have an orbital period. Now, Leonids, specifically Leonids, they have their origin is a comet named Temple Tuttle, which has an orbital period of 33 years, which means that it goes around the sun once every 33 years. So we can imagine that since if the comet has just passed, then we'll have a brilliant meteor shower, lots of debris, fresh debris. We can see about more than 120 trails per hour. But as time goes on, say the next year or the year after that, the debris in that particular patch of the sky becomes lesser and lesser and lesser, and the number of meteors we see will also reduce until the comet comes back again. So meteor showers have this particular factor, which is why you might not be able to see like 120 meteors every meteor shower. That does not happen, but it's everything good comes slowly. We need to be patient for something good, and from personal experience, meteor showers are some of the best things to view in the night sky. Once you see a meteor shower, you will never say no to seeing it again. Let me just quickly explain to you why they are called Leonids or Eta Aquarids or Geminids. So when in the night sky, let me just quickly stop share right here. And okay, so in the night sky, the meteorites, the meteors that you see in the meteor shower, if you trace their path back to where it apparently came from, they all seem to converge at a point, which is called a radiant, and that point is in the constellation of Leo, according to us. So we see it as if they are coming from the constellation of Leo, which is why they're called Leonids. So it's the same thing with the other meteor showers. So if someone says they are Geminids, then they appear to be originating from the constellation of Gemini. Their sources may be different, and there's a whole bunch of things you can do to view meteor showers. The best thing I would say is to just find a good day or a clear weather or a clear night sky, and just lie down on ground. Maximize your field of view. It could be anywhere. So a blaze or a streak of meteor is very fast and you don't want to miss it. So I suggest you lie down and just observe the night sky. And the darker the night sky, the better it is. Your chances go up. This year, there were the peak happened on the 16th and the 17th of November for Leonid. So the duration of the meteor shower is from November 6th to the 30th, and the peak is when Earth is crossing through the thickest debris of the comet path. So if you're feeling adventurous, you can go outside tomorrow night or day after and still see it. And if you want to plan ahead, there's Geminids that will be coming up in December. So do watch meteor showers. They're some of the most amazing things you can see on the Earth. And so now we're going to, I'm going to hand it over to Rick again. We're going to talk about Planet Watch. So here it is, Rick. Back to you.
Thank you very much, Spoo. That's exactly right. And so sometimes it's frustrating because you do have to have a lot of patience, and we are in a big city, and sometimes the city lights obscure what we do. But I've done this a number of times. If you just dedicate yourself to be in the dark for a period of time, try 15 or 30 minutes even to get your eyes accustomed to the dark, and just hang out. You'll probably see something. You'll see one or two certainly within 30 minutes or sometime after that. So try it. And unfortunately, the best time to do it is way in the middle of the night. So 1, 2 in the morning is the best time to get out. The sky's darker at that time. In the case of the Leonids, Leo is closer to the horizon by then, and so it's a little bit easier to see. So try it. We'll see what happens. We have no guarantee, though. You might find yourself frustrated. I think we have one more quick poll, and then I'm going to show you Planet Watch, and then invite you to sort of like give you some upcoming things. Is that right? Do I have that right?
We're going to do this poll very quickly since we're running out of time, but this next poll is our final poll, and I'll go ahead and launch that now. And so it says, have you noticed the changes in the positions of Jupiter and Saturn in the last month? So yes, Jupiter and Saturn now appear closer to each other. Absolutely, they are moving away from each other, or not really. I do not planet watch frequently. So go ahead and answer poll what, or the final poll, but question 1. And then question 2. Did I word that backwards?
No, good. Yeah, no, that's right.
Oh, okay. And then question 2 says, what did you observe about Mars in the last month? So it rises after 9 p.m. every night. It isn't red anymore, or it rises earlier every night and is currently almost overhead at 9 p.m. So go ahead and cast your vote. And I'll stop the poll.
I love this because it looks like there's some confusion about Jupiter and Saturn. So kind of like try to get you organized with that. Yeah, but people sort of seem to be watching Mars, and that's really, really good. So the idea behind this program is to kind of introduce you to things that you can just go out and find yourself. And so it gives us great satisfaction if we can show you some things on the screen, and we can kind of talk about some things in this virtual world, and then you're going out and experiencing them yourself. That's really super cool. I'm going to share a screen here. This is a little bit of a different view. And what I have here going for you here is sort of a view off the Earth. I can fly this. Let me just sort of like get a little closer just to prove my point. I can sort of like get in a little bit. This is the United States, and it's dark. I can even sort of, if you can see my cursor, this is Phoenix right here, sort of the Phoenix lights. That's Tucson down there and Vegas up there. You sort of see where we are. I'd like to do this every once in a while because I don't know, there's something about COVID, and there's something about us being sort of separated, and there's something about us sort of like not being together in groups anymore that I think make it more meaningful to sort of like just see how things are operating on a bigger scale. What does our Earth look like? Where's our place in Earth? How do we sort of like sort of organize ourselves in the big solar system? And so this is a view of the solar system. Of course, it's kind of fake. It's a model, right? Or the orbits are labeled here. You don't really see orbits in space. The blue one is the Earth. You can see to the left of the Earth over there, that's Mars. I have these planets blown up quite a little bit, so it's easier to see. But you can easily see way off in the distance for us in the darker part of the Earth, just kind of over on the other side from where we are now. That's where Phoenix is. And when we look out towards the western part of the sky, we see Jupiter and Saturn, and I'll be darned if they're not right next to each other. And we've been watching this for months. Let me just sort of like back out and show you sort of the relationship here. And I've only got a minute to do this. And so you'll see sort of a top-down relationship between the Earth, Mars, back out far enough, and you'll see Jupiter and Saturn come into view. There you sort of go. What's happening is everything is always moving. The Earth is actually sort of moving in a path that's getting further and further away from Jupiter and Saturn, but you can see how separated they are. And so as we move, let me see if I can get my cursor here, we're going to move in this particular direction. We're moving around behind the sun, and so Jupiter and Saturn will be hidden pretty soon. What you get to see from Earth is they will indeed get closer and closer and closer together, and then they'll get closer and closer to the sun. They will be kind of closer and closer to the horizon as the sun sets. The big culminating evening is going to be on the winter solstice. By December the 21st, the two objects are actually going to pass each other, and they're going to pass each other within 6 minutes of arc. And we'll explain more of this in 2 weeks, right, on the 2nd, and then we'll have another chance to explain this on December the 16th. But it's been an amazing season to watch the planets. It's been just fun to sort of, and I can see from the poll that we just took, some of you are following, some of you are getting out there, some of you are observing what's going on. Watch closely over the next couple of days. The planets will get closer and closer together. They'll get closer and closer and closer to the western horizon by sunset, and within a month and a week, they'll actually pass each other, and we'll be able to see that. We're trying to put together a special program for that. That's amazing. 6 minutes of arc is 1/5 of the width of the moon. So that's how close these objects will look to each other. Keep your eyes open, keep looking up, keep going out in the night sky. This is we have the perfect weather right now. If you're not taking advantage of it now, then we're in trouble. Okay, so I've already said it over and over again. We're going to come to a close here. I'm about to close out the night. Please join us again 2 weeks from now, December the 2nd. We're going to have a presentation from a couple of students from the what we call the cosmology group on ASU campus. They're going to talk about the Hubble Space Telescope and some deep space work and research that they're doing. Alicia is going to lead a huge discussion about welcoming Orion to our night sky. We're going to learn about Orion and all of that stuff. And then 2 weeks after that, we're trying to organize a night where actually it's Innovation Week at ASU. So we're going to kind of organize our evening program to talk about innovation. And we also have promised people some native stories. And it's the time of year we can start talking about native stories and get that going. I can see the 8 o'clock hour is here. Thank you very much for participating. You're going to get a survey in your email in a couple of days. Please take advantage of it. Answer some questions. Ask us if you want to see anything. We do watch those. We follow them. We use them to sort of like put together our programs. And I really, really appreciate your attention tonight. I hope you had as much fun as I did learning about the story of Andromeda and Perseus and the King and Queen of Ethiopia. Thank you very, very much. Thank you, guys.